So we've talked about different switches. We've talked about normally open, double pull, single throw. We've talked about a double pull, double throw toggle switch, so it's not a momentary switch. And we've also talked about the normally closed switch that would be in a door latch system. But the question is why? Why do we need to know so much about switches? Well, maybe it's not that much, but what we need to know is how they operate so we can diagnose them. You need to know how to use your meter in one of two functions. The first function would be in the ohm function. To do resistance checks on these switches, you need to have power disconnected from the system. Otherwise, you're not going to get a good resistance reading, or you could damage your meter. The other way you're going to test these switches is using volts DC in the circuit itself. And that way you can test these switches while they're still powered. That is a great way to test. But you need to know what the numbers on your meter should actually read. And so just a quick review, let's use this one, this normally open switch. So normally open, if we're using a resistance check between the terminals in its relaxed hands-off state, should have an open or OL between these terminals. When we apply the switch, it should go to a 0.1 or 0.2 ohms of resistance, saying that has good continuity. If we're doing a voltage drop check on this switch, with the switch open, what is assumed here is that we have positive connected here. So our battery is connected to the positive terminal here, and our load would be connected to this terminal right here. So going into, let's say, the light and going to ground. When we don't have continuity, essentially there's ground here and there's positive here, much like you'd find on a battery post. So if you were in volts DC, you would read open circuit battery voltage at this switch. So if your battery at your vehicle is 12 volt, you would read 12 volts across the switch. If you close the switch, so you're at that 0.1 ohm position, we would expect a switch like this to not create a voltage drop. If it created a change in voltage, that would be an indication of the resistance in the contacts. Now it's possible that it ohms out perfectly fine, but the minute it heats up, it starts to move away, or the corrosion acts up, or the arcing happens, and the voltage drop rises. That's why both of these checks are really helpful. But what is an okay voltage drop on a closed switch? Well, on a small, low current switch that this would operate, this one's probably less than 10 amps. We'd have to check for a rating on it. There isn't one stated. But on a switch less than 10 amps, we would expect it to have less than 0.1 of a volt DC drop across these posts. More than that would be showing that we're seeing a consumption of the power in the circuit in the switch. And depending on the load, depending on the voltage drop, we're creating heat. So now an example of this. Let's say we have 6 amps going through this switch. I know everyone hates math, so I'll do it for you. Let's say you have 6 amps going through. And when you test it with the switch closed, we have a 3 volt drop across this switch. Well, 3 volts times 6 amps would be 18 watts. Now, that might not seem like a lot, but when you think about your small pencil soldering iron that gets plugged in, a lot of those start at 11 watts and go up from there. So that means you can start melting solder at an 11 watt soldering iron. So 18 watts of voltage drop on a switch means that this switch gets hot enough that the plastic casing starts to melt. And some of you have removed switches that are deformed. They have melted away, or the terminals look black and arced and that they've changed shape. That is because they were suffering from a voltage drop before they were caught from their failure. And if they're ignored long enough, it is possible you could start an electrical fire. So the reason why we have gone through knowing what these switches are, their normal conditions and their positions, is so that you can perform either that resistance test, or if it's in service, the voltage drop test, and be able to make a firm diagnosis to be able to perform your repair.